log equations or logarithmic equations. So here we're going to use the theorem on inverses to solve for the example. X is equal to log with base 2 of 8. Now the theorem on inverses, it's like a raised to the power of log with base a of x. Here we canceled out the base a and log with base a. So that will be equal to x. So that's the first one. This is for x greater than 0. And then the other one is log with base a of a power of x, where the answer is x. So the condition here is where a is greater than 0 and a not equal to 1. So let's show you the answer for the first example. So without using a calculator, you can actually say log of or log with base 2. And since there is a base of 2 here, you express your 8 into a base 2. So that would be 2 power of 3. And by doing that, our answer would be just the power. Because according to the theorem on inverses, on the right side here, looking at the second one here, if you're actually having log with base a of a to the power of x, the answer is just the power. So it's like this one here cancels out. So the answer would be x, which is the power. So since we have the base here is 2 and the base, when we transform 8 into a base 2, they are just the same. So therefore, our answer is just the power, which is 3. Okay, next example. We're going to match the base here. So it says x equals log with base 1/2 of 16. So we're going to have log with base 1/2, and 16 can be expressed into a base 2. So that would be 2 power of 4. Because you got 2 times 2, that's a 4, times 2 is 8, times 2 is 16. So what we're trying to do here is use the theorem on inverses again. Since we have 1/2 as a base here, we have to transform 2 into a 1/2 by bringing 2 power 4 down and mix this as a fraction. So it's like this. Making 2 power 4 as a fraction, we will move that to the denominator side, and you will have 1 over 2 power of -4. And then after doing that, we can actually move the power -4 outside, and we will do like log of 1/2, 1/2 now here, and then we move that -4 outside as a power. So in this case, we can actually use the theorem on inverses, and notice and observe that these two are the same now, the one that I circled. So you have 1/2 and 1/2 there. So it means that our answer is just the power using this theorem on inverse, this one, the second one. And our answer is just -4. Now, when you're using your calculator, just plug in your expression. So like this one here, just enter that in your calculator and press enter. You will have that answer -4 if you have a log-based function. If you don't have the log-based function, you can actually plug that in by pressing log 16 divided by log. The log that I mentioned here is with the base 10. It's the natural, it's the common log that's base 10. Okay, and you have that function in your calculator. You just log 16 divided by log 1/2, and then hit enter or equal sign, and your answer would be -4. So that's how you check using your scientific calculator. So every calculator has different functions, so just look at yours. But the common log is actually one button in your calculator. And if you do have log function, just press the math button so you can access the log-based function. So that's the first two examples. Okay, another example. What if your x is on the base, and we have 8 here, and our answer would be 3. Okay, so we're trying to solve for x here. And then using the theorem on inverses, we can put x here and x on the other side. So that would be the base for the entire expression on the left and on the right side. So on theorem of inverses, this expression cancels out. So we will get 8 equals x cubed. And then we take the cube root of the left and the right side. We can express that by multiplying this by 1/3. So you can eliminate the power of 3 and do the same thing here. 1/3 as a fraction and as a power, it's a cube root of the number, or cube root of 8. So 3 here cancels out, and you have x power 1 or just simply x. What is the cube root of 8? Would be 2. So that would be the answer. because 2 times 2 times 2 would be 8. Okay, another example would be, what if the x is on the other location? Let's say like log of 2 here, x is here, and you have 3 here. So there are 3 possible cases that you can think. The x that we did on the first 2 examples, and this is the third one, that the x is on the base, and the fourth one would be the x actually in this location. So that would be log of 2, or log with base 2 of x. Again, that's log with base 2 of x equals 3. So in this case, we can actually use again the theorem on inverses. We put actually 2 as our base here for the entire expression. So we can cancel the log function here because x is trapped inside the log function. And do the same thing on the other side. So by doing that, the whole expression with the log here cancels out. So our answer would be x equals 2 power of 3, and that would be 2 times 2 times 2. So x therefore is 8. And you can see that from the previous example. And looking at the previous example, that must be the x that we put for the fourth example that we're looking for. Okay, so you can always remember this by doing a simple example first and remembering the theorem on inverses. Okay, and that would be the answer. Now, most of our answer before from linear equations, quadratic equations, we put this in a solution set. So you can always do that by doing the solution set here, 8, and the solution set here, 2. You can also check your answer by plugging that in back to the original equation. And obviously, in this case, that's the answer. Okay, so next problem. Okay, next example. So we will have log with base x, and you will get a fraction here equals 3. So note that the x is at the base here. So we can actually use the theorem on inverses again. And we can put x on the left side. So it's like I'm going to rewrite everything, so easier for you to visualize. X here, and then raise for the whole given expression equals x power of 3. So what you do on the left side, do also on the right side using the theorem on inverses. Now using the theorem, this whole thing cancels out. What's left would be 8 over 27 to your left here equals to x cubed. And then we take cube root on each side of the equation, so to eliminate the power of 3. So you can actually take the cube root there. A while ago we multiplied this by 1/3. That is just exactly the same thing. So this root or index 3 and the power of 3 cancels out. What's left would be just x on the right side. On the left side is the cube root of 8, that would be 2. Cube root of 27, that would be 3. Because 3 times 3 times 3, that's 27. Similarly, on the top, that's 2 times 2 times 2. That's how you get 8. So this is the answer here. And we put that in a solution set. 2/3 in a solution set. And that would be the answer for this problem in log equation.